All right, we are looking at solutions in chapter 12, and this is going to just be a nice short video looking at solubility. Okay, we're going to be looking at the solubility as it changes with temperature and pressure for both gaseous and solid solutes. All right, so let's look. We're going to first look at solid solutes. And so solubility is the amount of solute, the thing present in the smallest amount, that can be dissolved per amount of solvent. Okay, so the more solute you can dissolve, the higher the solubility. This picture, the graph here on the bottom left, is the one we'll talk about first. This is for a solid solute being dissolved in a solvent. In the case, our solvent here is water. And the solute that we're looking at is sucrose. So we're looking at sugar in water. And if you look, you can see on the X we have temperature. So as the temperature of the solution increases, what is going on for the solubility, the amount of solute per gram, I think, of the solution that we have here? All right, you can see that that graph is going up, right? The higher the temperature, the more solute you can dissolve. And this is a common thing I think you probably have experienced before. If you're trying to make a very concentrated solution, sometimes you will heat it up to get it even past the point where it normally would be soluble to even add more solute. Okay, so for most solid solutes that you put into solution, that's the case, all right? And so the next slide shows us, and it's a varying amount. It's not they're always going to be, the solubility won't increase all the same. It will depend on what the solute is. So you can see from here, ammonium nitrate, okay, that one goes up pretty dramatically with increasing of temperature. You can see glucose, the one we were looking at, okay, the higher the temperature, the more solubility you have. And most of them do go up that same trend. There is just one, okay, the cesium sulfate there, that actually sets a weird one out, but all the other ones go up, but that one, as you increase in temperature, it becomes less soluble. Sodium chloride, our table salt, you can see that one kind of slightly increases as well. So overall, okay, the generalization is the higher the temperature, the more solute you should be able to dissolve per amount of solvent. Let's look at the gas now. What happens with a gas? And so here's a little bit of a question. When I'm teaching in the lecture, I ask clicker questions and I make students kind of respond in to me to different questions. And this is always a good one where I get students saying, hey, where are you from? Because I call my soda pop still. So if you can make any guesses on where I'm from, where I call it pop, and people always think I have a little bit of an accent when I talk anyways. But if you want to keep your pop fizzy, where would you keep it? Think about it for a second. Where do you keep it? If you have a 2 liter of pop and it's been in the refrigerator, nice and cold, and you open it versus you have a really hot car and you've been keeping it there and you open it, what's the difference in the sound? Which one releases more gas, all right? So of course, if you want to keep it fizzy, that means you want to keep the carbonation in the drink, in the solvent, you don't want it to escape, you are going to be keeping it in the refrigerator, all right? So what does that tell us as far as solubility of a gas in temperature? Okay, the lower the temperature, the higher the solubility. All right, so we'll look at pressure effects as well, but as far as a gas goes, okay, the colder it is, the more gas can dissolve. If you heat up the solution, okay, now the gas molecules have more energy, and then they're going to be able to escape more, and they'll more easily come out of solution. So as far as solubility goes, lower the temp, solubility goes up. All right, let's look at the next slide as well. And this one, we have temperature effects and the pressure effects. We just talked about the temperature effects. All right, for a gas, as the temperature, let's see, temperature goes down, we said, the solubility goes up. All right, but let's look at now pressure. All right, so if you have a 2 liter of pop again, all right, and you want it to stay carbonated, you want it to stay with the gas in solution, would you leave the 2 liter uncapped or would you cap it when you are finished using it? Okay, what would happen if you just left a cup of your pop out? Over time, you come back to it the next day, does it taste as well? No. Why is that? Well, because if you leave it uncapped, you have now decreased the pressure, right? There's no pressure keeping it in there. And what happens? As the pressure goes down, the gas molecules are less soluble and they come out of solution. So you can see this according to the pictures here. This is a liquid with a gas in it, okay? And if the piston is raised, there's not as much pressure on the solution. And when the piston goes down, you have just increased the pressure. And you can see the different molecules involved here, okay? When the pressure is higher, okay, that's this case right here, you have a lot more molecules in solution. So as the pressure increases, the solubility increases as well. All right, so we have been able to look now at gas solubility and the solute solubility as far as pressure and temperature effects go. Next, we'll be working on some calculations.